Good morning students, I am Daniel, Assistant Professor, Department of Computer Science and Engineering, Pondicherry College of Engineering. So in this video class, I am going to teach you about what is finite automata and regular expression relationship. Okay, so last video class, I taught you about what is finite automata and regular expression. You know what is regular expression, right? R ij power k. So regular expression is denoted by R ij power k. So we have a theorem, that is what is the relationship between finite automata and regular expression. So already I told you finite automata is a machine model and regular expression is the easiest ways to describe finite automata. Okay, so that's what I told you. No need to have the states like starting state and accepting state. That's everything we no need. We can easily represent that by using regular expression, and it is denoted by R ij power k. Okay, so with one theorem we are going to prove the relationship between regular expression and finite automata. Let's see. First point is every language is defined by finite automata is defined by regular expression. Okay, so whatever the language we can describe in a finite automata, that should be defined by regular expression. For that, what we can do is we have to prove one finite automata, and we will prove that same finite automata, the string accepted in this regular expression also. Okay. Now we have two things to conversion, that is DFA to regular expression conversion and regular expression to DFA conversion. What it means? It means whatever the string accepted by DFA, that should be accepted by regular expression also. That's what the relationship. Okay, whatever the string accepted in the regular expression, that should be accepted in DFA. Can you understand the relationship between regular expression and DFA? Okay, so what we will do, we will prove the DFA and regular expression are equal. Similarly, the reverse order, regular expression and DFA are equal. Okay, we can convert from DFA to regular expression and regular expression to DFA conversion. We have two main problems. One is DFA to regular expression, another one is regular expression to DFA. So first we will see DFA to regular expression. Okay, DFA to regular expression. What is DFA? Deterministic finite automata, that previous video classes we studied. Okay, so in the one theorem, L equal to L of A for some DFA A, then there is regular expression is L equal to L of R. What it means is, whatever the language which have a DFA, that is equal to the language which have regular expression. That's what DFA to regular expression conversion. Right? So we have proved using two parts. One is basis part, another one is induction part. Basis part and induction part. So basis part we know, we studied in inductive proof. We will assume the value equal to 0. So here I am taking k equal to 0. So Rij power 0, Rij power 0. In basis part, a power should be 0. Okay. So we have 5 cases. One is Rij power, if there is no A. Okay, if there is no A means alphabet input. For example, only I or something, there is no A. If there is no A, but we have two states, I and J, we will represent Rij power 0 equal to pi. Can you understand? See, there is a two state I and J, but there is no input. So how we will represent that in regular expression is Rij power 0 equal to pi. Okay, this is useful for doing next problem. That's what I am telling you. So I will ask you, there is a two states, but there is no input. So how the regular expression is defined as Rij power 0 equal to pi, empty, pi. Okay, right. And the same thing, if there is a two state, but it reads one input A. It reads one input, that is A. See, there is a two state, but it reads one input A. So how we will represent regular expression is Rij power 0 equal to A. Okay, Rij power 0 equal to A. So I will ask you, if the diagram is like this, you want to tell the regular expression. See, if it is reads A, Rij power 0 equal to A. Okay, and if there is a two state, but it reads more than one input, A1, A2, AK, like this. See, there is a two states, it reads A1, A2, AK. So how we will represent regular expression is Rij power 0 equal to a1 plus a2 plus etc plus ak. Can you understand? There is a three cases I explained. See, if there is two state but there is no input, then Rij power 0 equal to empty pi. If there is two states but it reads one input, then how will represent regular expression? Rij power 0 equal to a. If there is two states but it reads number of input a1, a2, etc., a3, a4, etc., ak. So then Rij power 0 equal to a1 plus a2 plus a3 plus ak. Okay. And another one case, there is only one state. There is only one state. There is no path. It means it doesn't read anything. Then we will represent Rij power 0 equal to epsilon plus pi. Okay. If there is a two states, it doesn't read any input. We will say as Rij power 0 equal to pi. But only one state and doesn't read any input is Rij power 0 equal to epsilon plus pi. Okay. And if there is only one state and it reads one input, then Rij power 0 equal to epsilon plus a. Okay. If there is a one state, it reads many input. Rij power 0 equal to epsilon plus a1 plus a2 plus a etc. ak. So see, simply I will explain you the same thing. Simply I will explain you. So see, if there is a two state but I and j, but there is no transition. So how I will define Rij power 0 equal to empty pi. Okay. If you see this diagram, you want to tell the regular expression. If there is a two state I and j, but it reads a input. So how we will represent Rij power 0 equal to a. If there is a two state and it reads many input a1, a2, a3, etc., etc. So Rij power 0 equal to a1 plus a2, etc., etc. plus ak. Can you understand? There is a single state, it doesn't read only I, it doesn't read any input, that I will mention Rij power 0 equal to epsilon plus pi. Okay. If there is a single state, it reads only one input, Rij power 0 equal to epsilon plus a. If there is a single state, it reads a1, a2, etc., etc., ak, Rij power 0 equal to a1 plus, epsilon plus a1 plus a2, etc., etc., ak. That's what we described in the basis part. Can you understand this? The things. If I see this diagram, if you see this diagram, you have to tell the regular expression very clearly. If you have pen and paper, you note it down. Okay. Or you see my notes. I will give you. So see my notes and study. Okay. Right. This is the basis part. And see, it comes with the induction part. Coming to the induction part, that is, if there is a two state, you want to go I to j, there must be a three path. One is Rik and kj and kk. Okay. First Rij power k minus 1. Basis part I told you Rij power 0. Like that in induction part Rij power k minus 1. That is the thing, right? If there is want to go I to j, there is a Rij power k minus 1. And if you want to go I to j, first it should go Ik. That is Rik power k minus 1. And then Rkj, k to j, Rkj power k minus 1. Then kk, right? Kk. It means and Rkk power k minus 1, the whole star. Why I use the star is, it should go number of time, repeated time, right? Can you understand? Repeated time. So we will mention star. That's what I told you, closure property. Okay. So it comes like Rik power k minus 1, Rkk power k minus 1, the whole star, Rkj power k minus 1. Okay. If you draw this diagram, it will be easy for you. Then this is case 1. So Rij power k is case 1 plus case 2. This is case 1. And case 2, we have three things, Rik power k minus 1, Rikj power k minus 1, kk power k minus 1, the whole star. Okay. So it comes like, this is case 1, Rij power k minus 1, case 1. And case 2, Rik power k minus 1, Rkk power k minus 1, the whole star, into Rkj power k minus 1. So how you will understand this, Rij power k minus 1 is common, plus case 1, plus see Rik power k minus 1, Rik power k minus 1, now k star, right? into, this is very important, case1 plus case2 into rkk power k minus 1 the whole star. Why I use the star is it goes number of times into r, last one is kj power k minus 1. Okay, k minus 1. So this is the formula. You should remember rij power k equal to ik power k minus 1 into rkk power k minus 1 into rkj power k minus 1, right? That is rij power k equal to rij power k minus 1 plus rik power k minus 1 into rkk power k minus 1 the whole star into rkj power k minus 1. So this formula you should remember. This by using this theorem we are going to prove a problem, okay, from DFA to NFA conversion. So next class we will see the problem related to this theorem, DFA to regular expression conversion.